Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about dynamic hashing. We will first know what is a dynamic hashing, then we will know that what is an hashing structure on an extensible basis, then we will take a record and store the binary result to it and then input the record into an extensible hash or dynamic hashed structure. Finally, we will know that what are the advantages of a dynamic hashing over the static hashing. The file size, that is a fixed bucket, number of these buckets are not expansible, is the main concern of static hashing issues. Now when we talk about a fixed size of the bucket and also the number of fixed buckets, then we cannot just have the file for future performance issues. Now the future performance issues involve that we can have the file size grow or we can have the file size shrink, can have even the file go as an gradation. Now, if the size of the bucket and also the number of the buckets can grow and shrink according to the size of the file, then it is known as dynamic hashing. Now, we can have the size and the number of buckets according to the current file size. That means the file size will be expanding, then we can also expand the number of buckets and the size of the bucket. Now we can have the bucket size, a previously anticipated file size that which can grow in the future. That means the file can either shrink and grow, but we are assuming that more the company will flourish, the database size will grow. So we have that after 2010, this much of the software will be added up or the database will be there. After 2020, we can calculate from the heuristic search that what will be the anticipated size. Or we can have on the hand that while going the size of the current file with the size of the bucket and the number of these buckets. So in three of these scenarios, we are actually using dynamic hashing. Dynamic hashing means if the bucket size and the number of buckets can grow and shrink, and according to that we can compute the hash functions on the search key and then use the binary keys as a result, and which can be used to store the records in a normal file and then make a hash table which will store the value for the number of buckets and the size of buckets, and according to that which will in turn point to the actual values or the records. Now in this way the files will be stored of the actual content and there will be a hash table that will consist the number of buckets, all the bucketing order, and there will be a buckets which will in turn point to the records in the table. Now for more or less all general hashing purposes which is on an extensible basis, we use some chronologies. We use B as the bit of binary. That means generally we are considering extensible hashing for the large number of storing files and can have the B as minimum to 32. So we can have 2 to the power 32 number of entries, that is more than 4 billion we can accommodate in a single hashing like in the extensible hashing structure. Now also we can have the hash prefix. Now this hash prefix I supports that I number of this hashing will be preferring or denoting to I number of buckets. So the hash prefix I will consider all the bucket numbers as its index. So mainly there is one more level of indirection. First one will consider the prefix I to contain the bucket numbers, and in turn the bucket will consist the records. Now we can the list of the buckets. And each of this one will go to pointing the buckets here. So in this way we can create a general extensible hash structures. Now how the values on this lookups, insertion, deletion and modification on the data will hamper or provide the change in this hash structure on a dynamic hashing. Well, we do not create for 2 to the power 32 entries, that is 4 billion buckets for 4 billion entries. We just check a number b, that is a bit of the integer, and any value that belongs to 0 and b. That means we first create an ith number of buckets. That means I number of buckets can store the result, and according to the change in the file growth or the insertion record growth, we can change the number of records or the number of buckets in our hashing structure. So this I can grow and shrink, and but not this 0 to b range. So out of this range 0 to b, it will create an error. Other than that, any number ranges between 0 to b, it can store the number of buckets depending on the need of the current file organization. Now that we have chosen an I, we can also choose the size of I. That means first we can start with 2 to the power 0, that is one record. Now if there is one point that is referring to one information in the bucket, then we can just add 0 plus 1, that is 2 to the power 1, or 2 records in a file. That means one more bit we are attaching, then we can have a number of more buckets available to us. So depending on the number of bits that we are having for an information, we can attach it to 1 by 1 by 1 and have the result of 2 to the power of I as a result of the number of buckets. Now we generally follow bucket J can follow this number of entries into a bucket particular. So 2 to the power I minus ij means I is the number of buckets that we have chosen to have, and ij is the number of buckets on that current situation. So 2 to the power I minus ij can be the number of entries that is pointed by bucket J. Now, sir, look at the information on an instructor. We will one by one put into our hashing structure. Now for the insertion, which have calculated HK1. That means any value that is on the K search key, we are computing hash functions H on it. Now for the insertion, first we will check that the bucket is empty or not. If it is empty, we can directly put the values to it. And if it is partially empty, then we can also put the value to it. If it is full, then we can check for the next conditions. Now, if it is full, it is for bucket J, we need to check if I equals to ij, that means there is one entry in bucket I that is pointing to this bucket J. So we can just increase the size of the bucket other than increasing or splitting up the buckets before getting new records inserted to it. So we can have, if it is 2 to the power 0, that means I equals to I0. Now 1 will be added to it. So we have now 2 records accommodated in bucket J. Now it will record store 2 number of into the bucket J, and if there are more entries coming to it, then we need to split up the records. So first we need to split up the records into number of buckets, then we need to add the new record to any of the bucket that we have splitted up, and as a result we have a success on a new record position to store the record. Generally, it's success by one splitting. If it is not successed on the first splitting, then we need to perform again the size increment and again the size splitting on this number of buckets, so that we can achieve a particular position to store the new record that is coming on. Now the second scenario is, that is I is greater than ij. That means there are more than one pointers or records that is pointed by bucket J. Now we need to definitely split up our number of buckets without being changing to size increase on the bucket. So after splitting up the number of buckets, we can then add the information to the bucket J. Now if it is full, and we can say after splitting up also there is no space, then we need to size increment on that bucket. After that, we have incremented the size, we want to insert the new record, and for a final completion on a successful splitting up bucket and successful size increment, there is the 90% chance of having the new record inserted. If it is not inserted, then we again to perform this one and check this condition I equals to ij or I greater than ij. For once, it will happen. Now, to delete a record from an indexed or extensible hash structures, it's quite easy. We need to find the search key and then compute the hash functions on this hk1. After that, we can see on the hash table that to which a bucket the hash value is stored. So we can say that the hash prefix will store the indexes, and according to the indirection, we can find the bucket that is containing the particular information. If it is the one information that the bucket is storing, we need to merge up the bucket to the previous bucket and then delete the bucket from that information. And if it is more than one information that the bucket is storing, then we just simply delete the information, make an empty space into the bucket. Now with an example on the instructor table, we will perform all these three operations. Now the modification goes in hand just like the insertion and deletion. So first we will store the instructor table department relation within 32-bit hash value and then used first 1 bit of that each of this department name to use the bucket, and once we will have more than one record stored into the bucket, we can see that the number of bits we will increase and number of the size or the buckets we will increase too. Based on each alphabet that is the starting name, we can calculate the hash value, that is H department name, and generate the 32-bit numbers associated with that alphabet starting of this department name. So here we can see that 32-bit hash values associated with each of the department names. Now we will consider the first bit with each of the departments to calculate our values. First we will start with an empty table just with one prefix and one bucket that is also an empty one. So this is my bucket address table that is empty. That means it has got only one bucket, and the bucket which is 2 to the power 1, that means 2 entries, which is also empty. Now we will try to insert each of these records in it so that we can achieve the final one within all features involved in the indexed hashing structure. First, we want to insert the record 101 Srini Computer Science. So it is of Computer Science department. As we can see that it starts with 1. So 2 to the power 1, that means 2. There is no need to expand it. So we can have it stored in this bucket. So as a result, we can have this Srini inserted in Computer Science within 101. Now, let us move with this 1-to-1 Wu Finance. So the finance starts also with 1. That means there is no need to expand it. So we can also have it there. So after that, we have inserted this 2 information into bucket 1. Our hash table structure will look like. Now that we look for this 151 Music Mozart. Now in the bucket studio, we can have looked in this 32-bit hash values that M is got and 0. So 2 to the power 0 means 1, and that we cannot have this index 1 because it is full on this bucket. So there is no way to increase the bucket because 2 to the power 1 equals to 2. we can have at most 2 number of buckets on the size, so we need to add up one more bucket to it. So after adding one more bucket, we can have 151 in the new bucket. It will also be indexed 1 because it is belonging to not a separate index but to the same index, because it can have at most 2 number of buckets in this index. Now, if I want to insert the value 222 Elvis physics, so the first bit on HP, that is H physics, is 1, so it must point to any index that is belonging to 1. But as we know, there are already 2 indexes, 1 and 1, so we need to split up it and make another index 2 with this previous ones, and then make a new entry to the new one. Because when we are valuing the current one, we are actually calculating lower values, and while we are having the previous one, it is actually older values. So we will create a new index to our having the Elvis physics 222, and other this one, the buckets that was available will be put into the older versions. Now we can see we arrive in a condition that we have I equals to I1. When I equals to I1, if we can remember, then we need to increase the hash index equals to 2 to the power 1 plus 1, that is equals to 2 to the power 1, or 1 plus 1 equals to 2. So the new hash prefix will be 2 with the given new 2 tables as 2, with the previous one as 1. So 1 being the last one that was being referred, and the new 2 tables will be referred as 2. Now see, Wu has to be represented with this finance and the new one that we are taking it at Elvis and physics, because physics and finance both has 1 as its computed key, so they has to be created in the same structure or bucket. Now then Srini has to be moved to another one, just like the splitting. So the hash prefix 2 is belonging to same of these 2 buckets, just a part of this that Wu and finance and the previous one, because Wu was last inserted, and now we want to insert the same structure, like increasing the size of the table and make it Wu and Elvis Smith for finance and physics, and Srini goes for the last structure that was not increased with this number 2 prefix. Now if we want to insert the information that is 383 Emily on this physics, then we can have in this computer science, because the computer science is being freed and referred by this index 2 on this bucket table. But if we after this insertion on this computer science Emily, the 2 becomes full, because the first 2 bits refers to 0, 0 and 0, 1. That means 0 is being solved. Now 0 and 1 both are filled. So we have to next choose for this third bit on the next information that we will store. Now suppose I want to insert another information that makes up with, say, Pelvis and Emily physics on that one. Now that physics is another one that P is having. So physics is already being paired with finance, but now both the P's has got 0 and 1. So we have to next look for the next bit, that is 0, 1, 1, 0, 1, 1, both for this physics. Now as both of this has the same structure, so we need to increase the number of bits or the number of size in the buckets. But there is no, because 2 to the power 1, 2 number of information are already being stored there. So we need to split up the bucket, make this finance entry into the new one, and then combine the new entry to the physics one, as we are appearing, is I greater than ij. That means one bucket is pointing to more than one information to ij. Now we need to split it up. Now that we have the indexing on this one is 1, this one is 3 as the splitted up windows, and this one is 2 being the previous windows. Now these buckets that we will consider, Mozart and the computer sciences history will not be affected because they are not considered here. Only the physics is being affected because this physics and physics combination will be taken into this 2, and will V is considered as a splitted up and make an index it to 3. Now see, my index 1 will contain 4 of the pointers from this 4 or the first one to the index 0. So the hash 0, hash 1, hash 2 and hash 3 both will point to this index 1. Then we have this one pointing here, like in this way, because every one 0 1 2 3 always points to 1, because 1 was the first, that is 2 to the power 0 equals to 1 being, because if every reference that we will add, we will add a pointer to the first one as being the first index. Now we will try to add more information to it. Now what happens if I want to add one more information to the computer science department CADS? Now the computer science department has this 1010 as this one, and 10 and 1 already being served, so we should look for this next one 0. As we are appearing with I equals to I0 condition, so we need to first increase the size of this bits on an bucket. Now this bucket will size that the computer science will be paired up with each other while making and splitted up this history into another one. So now after this 7 insertion, my hash table and this bucket will look like. See, we have not increased the index because we are already increasing the size and adding one bucket to it, but the index is equals to I0, so we are previously happening the I0 as the next I. That means 3 was the previous index, we will use as this the current index. But we have to split up the table because history cannot be accommodated with any of the music and finance that is available with the size. So now all my index will be 3 other than the last one, which was used the 1. As we are splitting up these tables, so we no need to increase the index, just make this index with the previous one and making it a new one, so we need to increase the index of the last one. As we can see that the computer science and history was combined together with the index 2, but I want to add a new insertion on this computer science department, so I need to change the index from 2 to 3, and now history is being splitted up into another table, so it will also point to another index 3. See, history is being splitted up into this one, and now we will add 2 more entries, that is one previously having computer science and one new computer science. See, as no new index is added up, so the last 4 index will point to this one, and now each of this will point to each of the table. Now we will insert one more values or two more values to see what are the insertion problem that we can face here. Now we will insert three one. One is for this finance, another is for this computer science, another one for this biology. Now going with this biology, we can directly add it here because we are adding up one table on this one, music and biology both having 0 and 1 as this first and second digit. So we are facing I greater than ij. So we can just add it to this first one because I is the 2 and I1 is this ij, that is 0. So we can add this one with this Mozart because this phrase is free and we can add it without splitting it up. So the biology information can be added up into the first one. But see, as we are actually having the size of this increment on the bitmap or this bucket, then we can have the increment on the index 2 because now it is being referred as a new one. So we need to increase the number of indices. So 1 will become 2 now. So after that, on this 3 insertions, we can have on this 2 here. So 2 will be for this one. So let us now increase this index and make it one fresh one. See, as we have not split it up the table, so we will not increase the index of this hash or the bucket table. We will just increase the index of the bucket because it is the new one and new information is added to it. So here we can add this biology information in this 2 block because we can have the 0 and 1 of the biology and music and aim and B as same. Now if I want to add one more information on the finance, see in this finance group both is F and now there is one more information and the space is available here. So there is no need to increase the size of this one and no need to increase the actually number of buckets or splitting it up. So we can just include the finance department information into this one. So now we can have what happens if I want to add in computer science information now? So the computer science cannot be accommodated in any of this and not this history because H and C doesn't match with each other. Now this we are considering the fourth bit, so the fourth bit of H and C will not match. And the computer science is also filled up, so we cannot split it up and we cannot add more of the number of size on these buckets. So what we need to do, we need to overflow the bucket with the bucket chaining. That means we are adding up with the static hashing concept into this extended hashing as a bucket overchaining. As this overflow cannot maintain without this size increment because 3 of these functions computer science is giving on the same hash value because they are belonging to the same group C, and now we can just have splitting up these tables. Also we cannot just increment the size of this bucket. So we need to adjust one more as an overflow or the overflow chaining. See here in this one, we have not given this bucket as a separate index because it is considered to be a chain to the overflow of this third index on the bucket. So in this way, we can even create a chaining of the overflow. And lastly, we will insert any department from electrical engineering. So the electrical engineering is also happening on the hash value, that is 10 and 101 100. So now we can conflict that 10 is already being served, so 1 and 0 is the mismatch. So we will insert this electrical engineering in the new bucket containing a new record. And we cannot just merge it with history, because h on this third value comparison, which is possible for this 0, cannot let us insert the value into this one, because we cannot increment the size if we can have the condition I greater than ij. And now there is no need to splitting up the bucket, because we have to add a new bucket to it, because there is no existent information on electrical engineering. Now we want to add more information to it, that is 983 Kim Electrical Engineering. So we have split it up this table, and now this new table 983 Kim Electrical Engineering. So my indexing is like the previous one we have made. So this one will be considered as 2, because it is a new one and only 2 to the power 1 plus 1. So 2 is my new index that we are fetching for this electrical engineering, not 3. So now this next 2 fields that will point to this 3 on both the cases. So now this all indexing is being made, and we can have all the departments and have split it up and seen that how extensible hash structures can be used for storing the data, increasing the size of a bucket, number of buckets, splitting it up, and then also overchaining or this indexing. Now, if we computed this number of this dynamic hashing over the static hashing, so the dynamic hashing can grow on a file size if it grow on the information. So we can see that started within one bucket, we have ended up with 7 buckets. Also, we can add more information on this more buckets by having overchaining method on the static feature. And now also that the index tables is generally slower, or this generally shorter than the static one, because we can have more than 2 indexes pointing to the same bucket, and that reducing the overhead of keeping it. One disadvantage to it, that there is one more level of indirection for keeping this bucket address table, but it is the minor one, because other advantages if you compare with this static hashing, which does not provide any of this fixed number of buckets, and also the bucket increase on size and number on the file growth. So it generally degradation file performance, and if there is a need for extending it, so it can support it by this extended hash structures or dynamic hashing. So that is all for today. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.